we have Joe Ben and Adam Goldstein collide in an amazing interview with a bonus guest this time, the great Brian Yotka from Wisk. This has been carried out by the All In podcast team, so make sure to strap yourself in for the next 45 minutes because it's full of exciting developments and must not miss revelations in the Evtol industry. Let's not waste no time and get right into it.
For our next panel, we are going to have a quick introduction to each of the three electric vertical takeoff and landing vehicle companies, the Evtol companies. We'll see a video for introducing Joby, and then Adam from Archer is going to introduce Archer, and then Brian from Wisk, and then we're going to have a conversation. Be back in a minute.
I do love the push for hydrogen from Joby though.
I founded Archer in 2018 to change the way the world moves. Urban congestion isn't sustainable. This leaves the average American stuck in traffic for dozens of hours per year. To combat that challenge, we built Midnight. All-electric aircraft purpose-built to fly back-to-back trips over congested cities. Midnight takes off vertically like a helicopter, then its propellers transition down to fly like an airplane. It's designed to be piloted and carry 4 passengers and can travel at speeds up to 150 miles per hour. Since 2018, we've made an incredible amount of progress to bringing the Midnight aircraft to market. Our nearly 1,000-person team has designed, built, and tested the key enabling technologies to bring electric aviation to market. This has enabled us to raise nearly $1.5 billion to date. However, our goal is the same since day one: to get to commercial launch. Our high-volume manufacturing facility in Georgia will open up later this year, and we have incredible partners that are helping us bring this vision to life. Stellantis, the owner of Jeep, Ram, and Maserati, has invested nearly $300 million to date. United Airlines has ordered up to $1.5 billion of Midnight aircraft. And with Southwest, our goal is to offer passengers 3-hour multimodal journeys across California. We have an industry-leading contract with the Air Force, and we recently delivered our first aircraft as part of that contract. In LA, we recently announced plans for flight networks connecting SoFi Stadium, USC, LAX, and beyond. We can't wait to bring Midnight to a city near you.
Get them in. Peter Thiel reminded us yesterday that flying cars are the peak of the hardware revolution that never quite happened. But as you just saw, we're closer than ever to making it a reality. The aircraft that the three of our companies designed take off vertically like helicopters. They do a complex maneuver to transition onto the wing into wingborne flight and fly like an aircraft. When the founder of our company, Larry Page, first joined this mission, the technologies that enable these aircraft to fly were just starting to become possible. The team that I lead has built the enabling technologies in electrification and autonomy that's making this possible. You see the prior 5 generations of aircraft that we've designed here on the screen behind me, and that iterative design-build approach has enabled us to get to the point where we are building now Generation 6, which is the first candidate for an FAA certification of a passenger autonomous aircraft. This aircraft is designed to take advantage of all of the prior technologies that we developed through those prior iterations and to operate without a pilot on board on those missions.
Now, let me know below if you want me to do a deep dive on Wisk.
There's 2 technology trends that we are all using to create these aircraft. Motors and the same simplification that's coming to your cars, and batteries and the same advances that are coming to your cars and also to your cell phones. And second, autonomy. And autonomy has a lot of parts to it. So we have to, for the first time in a commercially certifiable way, show how we can operate and supervise an aircraft from the ground, display information in a way that is safe from a human factor standpoint to supervise that aircraft, to use sensors on the airplane in the same way that you would for an autonomous ground vehicle, to create the software and the computation to be able to then fly that aircraft autonomously. But when you make robots, people don't go away. They change what they're doing. And so we use those aircraft to actually do deployment testing in networks. Here in Los Angeles, last year, we flew the first electric VTOL aircraft in the Los Angeles area, and we showed what's possible with these aircraft and how people can engage with them. We are also working on the human interface with air traffic control, because again, even though we have an autonomous aircraft, our aircraft still has to interface with today's air traffic control system. Like what you saw yesterday from Waymo, we use existing flying cars, aka helicopters that are piloted, to take that sensor package and those computation abilities and put them onto a piloted helicopter to perfect the algorithms that we use for doing things like detecting and avoiding other traffic in environments where there's different lighting and where the aircraft that you might collide with potentially that you want to avoid is above or below the horizon. We also have to be able to fly these aircraft without the presence of GPS. As we see in conflicts around the world today, we cannot rely on GPS to be able to fly an autonomous aircraft. So now once you have that technology stack, you need to turn it into an actual airplane. And all the things that Peter talked about potentially being a bad industry to go into in the 90s are now becoming ever more important. The ability to do aerodynamics, to do mechanical engineering, to create these aircraft are now more important than ever. And by the end of this year, we'll be flying this aircraft, which will be the first attempt at certifying a passenger-carrying autonomous aircraft. So let's bring the guys out and we'll talk about it. All right.
Well, I think that there's a lot of people that probably need an introduction to VTOL in a more basic way. Before we talk about the technology, whether it's the actual vehicle itself or whether it's the world's best pilot, if you will. Mm-hmm. For the folks out here, if they are going to interact with these systems, whether autonomous or not, what do you think are going to be the biggest issues that they are going to care about and will want resolved before they see it in their community? Maybe Joe Biden, if you want to start.
Now, before we listen to this, let me know below what you think the biggest issues facing the VTOL community is.
Yeah, I think the number one issue for everybody when you're getting in an aircraft is this going to be safe? But then for both the passengers, what they care about is something that's going to dramatically change the way they move around their cities and save them time. And in order to do that, you need to have takeoff and landing locations that are located both close to where you are and close to where you want to go. And so priority 2 through 9 in people's priority stack is about noise and making an acoustic signature that's going to get communities to see this as a real advantage and something that's increases the value of living in that community because you're close to this new mode of transportation.
Do you guys think that when you see 1,000 of these things flying around, let's just take a place in Menlo Park, California, are they going to be forced to have very specific sort of like air highways that they have to adhere to, or what is the best thinking right now in terms of how?
No, this is an interesting question. I never actually thought of this one myself, so I'd like to hear the answer here.
The regulatory bodies are going to sort of enable you guys to actually fly commercially as quickly as possible. Hey, Brandon, turn to you.
If we just take a step back, the product exists. They're called helicopters, and a helicopter is actually way more complex than what we're building. We're actually building a much more simplified version of what exists. It's safer, it's fully redundant, and so it should inspire confidence for people to want to come and take these vehicles. The way they'll start, though, is going to be really slow. If you think about every major city in the world, they have hospitals. Those hospitals have helicopters. This product exists everywhere. So if you took all three of us, you took our most bullish estimates that we have, and you triple them, we still would not even replace helicopters. So to get to the point where you're asking thousands of vehicles in the air over one city or even hundreds is pretty far away. We could all deploy tens of thousands of vehicles. We could, the three of us, be $1 trillion companies, and there still would not be $1,000, well, hopefully, there still would not be, thousands of vehicles in the air. But.
And this shows how big the industry can be once they get certified.
To make the product really, really great, you do want liquidity. You do want a lot of vehicles on dense routes. So you don't have to worry about, is it available, is it not available, like an Uber, right? It's thumbs up, it's available, or it's thumbs down, it's not available. It doesn't matter what seat you get, it saves you time. That's where we're all trying to get. But I think just to frame it.
Sorry, Adam, is it a thing where it is like Uber where there's going to be a version where you get in with people you don't know, or you think this is just
absolutely.
Like one person provisions it for themselves and then they go from point A to point B?
No, absolutely. The vision is, a service that's available for everyone. The good news is you can scale these vehicles because they're just much more simple than helicopters. We don't have all the limiting factors that helicopters have. So you can put a lot more of them in the air. You can push the prices way down and make it very affordable.
Brian, yesterday we heard
it's also
from,
a dramatically faster trip. So you're in it for a few minutes to get across LA instead of in Uber where you might be sitting in traffic for an hour or two.
Right. Yesterday we heard from Takeda, from the CEO of Waymo. Their first launch city was Phoenix. The layout was good, but mostly it was really regulatorily amenable.
Yeah.
Brian, what is the version of Phoenix for eVTOL? Is there a city somewhere that has said, we want this now, come and help us figure this out?
Yeah, Houston. Houston is where we're working most specifically. And it's not just because Woody lives there either. But seriously, Houston is, the airport network in Houston is actually quite good, connecting a couple of the airports around the Houston area. It turns out that operating at airports initially is actually quite a good place to start because, like I said, these aircraft, they come with a footprint. They really come with like people and operations. And if you've ever seen an airport tarmac area, you can't just drop that in the middle of a city on day one. So starting at airports as an initial operating area is quite good. It turns out, what you saw in that video was from an airspace integration standpoint and where we were going on routes and so on. New Zealand has been incredibly forward-thinking in terms of how to evolve their airspace network so that they have more digital communications, more of an ability to integrate uncrewed aircraft with crewed aircraft in the same airspace. And so we've been doing quite a lot of work in New Zealand on that front.
But hold on, I think it's, to me, super clear this does not start in the US. I really think it starts internationally. I think the regulatory environment here.
Where, Adam?
both
Now, the United Arab Emirates are the front runners for this.
both of us work in the UAE pretty extensively. I mean, if I'm going to guess, just on the press that you put out, Joe Ben met the head of the Civil Aviation Authority in the UAE yesterday. I'm leaving tonight on a plane to go meet him as well. And so, we are targeting Abu Dhabi. They've been targeting Dubai. And the reason is there is a very heavy support for new innovation. And the challenge, like the reason why I feel like all three of us are up on stage here is probably because of the whole Woody video that we just watched. We all learned about NASA as young kids and were inspired by new things.
Yeah.
But the challenge is the existing environment today makes that very hard. And these are companies that were started in America with American engineers that have raised capital from the American venture community that are listed on the American stock exchanges, yet we still can't launch in America. And that is really challenging. And I think part of it is back to what Bill Gurley talked about last year, regulatory capture. The walls are huge to climb. And in fact, the more things go bad with the incumbents, the harder it is for us. I don't think that's done on purpose, but that's very challenging for us now.
I would say that the amount of bipartisan support on both sides of the aisle in Washington is off the charts. The amount of local support with states. Yesterday I was in Montreal at the International Civil Aviation Association conference, where they convened. This is the first time, and they were convening 1,800 people to focus on advanced air mobility. And so this is really exciting to see how much momentum there is, and it's imperative that the U.S. continue to lead. Aviation is one of our most important exports. It's been vital to our economy, and it is really, really important that we lean forward and we make the certification process and
Just to double click on this for a second, I can see how Joe Ben and Adam, you guys, pure play startups, you have to find the willing parent. But you have the benefit of Boeing. And is that why your answer was Houston? Is because they have that, I guess, regulatory gravitas to be able to go and help there? Or no, you're still mostly on your own trying to figure this out?
Yeah. The journey of our company was obviously, started by Larry.
Started by Larry Page.
Became Kitty Hawk, turned into a joint venture, and eventually we sold the company to Boeing last year. And so we still operate as an independent company, a lot like the Waymo Google relationship right now. For us, the difference is we're really trying to pioneer the pathway to the introduction of autonomous aircraft at the same time. And that's a longer journey. So Joe Ben and Adam are going to be operating before us. There's no doubt, because piloted aircraft are coming before these uncrewed aircraft. I think autonomy is key to the future of aviation in the small airplane space. If you look at the causes of incidents and the accident rates in helicopters right now, they're just unacceptable. And I think that can be solved via automation. I'm really passionate about that. So for us, we're on a longer journey. And the question is then, on that journey, how do we make sure that the US leads in that? And we're trying to pioneer the regulatory pathway to ensure that it happens here in the United States. But we're also working around the globe, like I mentioned in New Zealand, where there are regulators who potentially want to lean forward and innovate on airspace or some other aspects of the problem that we're trying to solve.
I mean, Adam mentioned the concept of regulatory capture, but one of our besties, Sky Dayton, who's on Joby's board, wrote this great essay. And one of the things that's clear is that a lot of the pushback to the vision that you have, Brian, actually comes from the pilots' unions themselves, right?
I think
it's a bit of a weird set of incentives. No, do you want to just talk about that for a second?
I think it's less salacious than that and more clinical. I mean, I'll give an example. Well, so my vision for the future is that we're going to have a prolific amount of uncrewed small aircraft that are operating, doing the kind of missions that we're just talking about, but that large aircraft are going to be piloted for probably as far as the eye can see. I think the practical aspect of it, honestly, is that in 2023, here's a statistic for you that just blows my mind as a developer of airplanes. In 2023, there were 30 million global flights, carried billions of passenger enplanements, number of people that got on board the airplane, scheduled service, airlines, 0 accidents. 0.
What?
0 in 2023. Zero.
Wow.
So it's less salacious than there's a cabal that's trying not to certificate things. There is a natural conservatism in the system of holy cow,
It's working.
we've done it. It's working.
Don't touch
Don't
it.
change it.
Right.
So when new technology shows up, I understand the perspective of a regulator that's sitting on the other side of that wall and is saying, man, this is kind of working. Now,
Okay, then just to put you on the spot, I mean, I can see, when Joe, Ben, and Adam say, hey, point A to point B, instead of hours in traffic, you're there in 10 minutes. If there are really no pilot errors, unlike in cars where there's still far too many unnecessary deaths, how do you measure the incremental justification for the investment, let alone the reason to
the
switch?
statistic that I just gave you is for large aircraft, scheduled air carriers. If you then look at the small airplane market, or you look at helicopter markets, it is orders of magnitude. It's infinity more, but it's way worse. And so the question is, how do you bring the level of safety of those large aircraft? How do you bring that same level of safety down into the small
Get rid of
aircraft?
recreational pilots.
You have to start. You just have to start. I mean, there is definitely, this panel exists in China. And guess what? There's 2 groups that are already certified there. They started. That's how you do it. You have to get moving. You have to set an environment where we can all start flying stuff. When we can do it A to B and
When
hopefully here.
you're using a large aircraft, you're dividing the 2 pilots' expense amongst 300 seats or 100 seats. And in this case, you would have a pilot on a Joby flight which really, the pilot's not doing anything. They're not flying it. So they're there to make the passengers feel safer, is my understanding, yeah?
The pilot, there are, even with what Brian's doing, with the incredible pioneering work on autonomy, you still have somebody on the ground who's making sure that the weather is going to be safe and lots of other operational logistics. The benefit is you get to take that person out of the aircraft and put them on the ground, so you get to put another passenger in the aircraft. You get a lot of operational flexibility because you don't necessarily have to have the pilot and the plane at the same location at the same time. A pilot can, over time, begin to operate multiple aircraft at the same time.
What does the pilot do in a Joby? Because my understanding is it's automated, so they're sitting there just monitoring it.
They're making sure that all of the operations are going to go safely.
But they're
The
not
pilots
on a
are
joystick.
flying. There's sticks, right? I mean,
There is the option for the pilot to fly with the sticks as well.
So in an emergency situation, they would take over, but it's autopilot essentially.
There are a lot of computer systems that are helping the pilot fly.
And when one rotor goes down, I mean, one of the great things about this is when you have a helicopter, a rotor breaks, you die, essentially.
We have layer on layer of redundancy. We have
so many.
six propellers, and each one's driven by separate motors, with each separate inverter, with each a separate battery pack. And so it's just, the same thing with the flight computers and the...
Everything's massively redundant.
Exactly.
What would it take
and that's what we did in big commercial airlines, which is why you get the incredible safety that Brian was talking about.
Yeah, I mean, we haven't had a passenger death in the United States. I think the last one was 2009. And the last 3 passenger jets that went down in the United States were all regional jets, which we all know that there's a collection of problems there. So what would it take, theoretically, when you're doing your edge cases? What are the edge cases that are the most challenging in terms of safety?
Well, so, with our initial certification, we are not certifying for flight in known icing, for example. So if you live in the Northeast, there will be a few % of the time where we won't be able to offer service.
You'll just ground them during ice conditions. You're not going to JFK when it's snowing.
Well, when it's snowing, you may be able to go, but if there's certain conditions where you get heavier
What's after
icing.
icing in terms of concerns and things that could make these go down?
Exactly. So
And is there anything else though that could, that
what's
you're
the wind speed or gusting kind of condition max and so on?
So we're actually very tolerant to that. It was interesting yesterday.
Probably better
than
than a winged aircraft, I would imagine, right?
Right.
Yeah.
And so there's these folks at NASA who are working on wildfire prevention.
Yeah.
And they came and did not the wildfire prevention folks, but NASA came and did an acoustic survey where they put out a whole array of microphones, and we flew the aircraft in hover and in transition, overflight, et cetera, and measured the acoustic signature. And showed that it was really low and could fit in the environment. In terms of, but yesterday I was having a conversation with them on wildfire prevention. They're like, these kinds of aircraft are going to be game changers for wildfire, because with helicopters, they can't handle really turbulent conditions. When you've got lots of convection from the wildfire. And
you have 6 motors.
We have 6 rotors, and so there's this thing called vortex ring state that affects vertical takeoff and landing aircraft, and you aren't going to have all 6 rotors go into vortex ring state at the same time. And you can also, one of the cool things they found out with the Osprey is if you just tilt the rotors forward, that you can very, very quickly get out of vortex ring state. So basically, these new class of aircraft and what you can do with electric propulsion, and I don't think we've talked about that enough, is what a game changer electric propulsion is.
Can you talk about the acoustic issue? So give us some context for the decibel tolerance. What was in a city, and give us a comparison to stuff that exists today, a big truck, diesel truck, helicopter, and what do we need to be at for this to be ubiquitously accepted in cities?
Now, this will be interesting, because if they're flying thousands, you don't want the sound of a helicopter multiplied by 1,000.
And then what's the technology needed to get the acoustic breakthroughs needed?
Yeah, so the background noise level in cities is around 65 decibels. And so we set that as our threshold for this is the level that we want things, want our aircraft to be below during takeoff and landing.
You don't want to be beyond background.
Right, we want to be below 45 decibels in overflight, and we've achieved both of those goals. You asked about other things. I think a garbage truck is 80 or 90 decibels.
They're the worst.
Exactly.
The worst.
Every 10 decibels is an order of magnitude more noise energy. So it's, a jet engine is like 110 decibels. Helicopters are between 80 and 100 decibels. The other thing about helicopters that people find really annoying is it's this low frequency wop wop. And that low frequency sound travels long distance through the atmosphere, and
so what's the tech needed?
It shakes buildings and really noisy.
What's the tech needed to bring the acoustics? How hard is?
Well, when I started Joby in 2009, so it was 15 years ago this week. So it's like I've been working on this a long time. I've been dreaming about it since I was a kid. And it's incredible to see the industry that we've built, and again yesterday to see thousands of people gathered just to focus on all of the issues of bringing this to their cities around the world. So that's really exciting, and the rollout and the impact that this is going to have on cities is just really, really exciting.
So let me ask you guys.
You're effectively you're spinning the propeller slower. That's what you're doing. That's what electric engines do. That just create lower noise. That gets you 90% of the benefit, and then from there you work to all the little efficiencies to get that stuff out.
So let me ask you guys about the convenience of owning a car, and America kind of popularized this idea that everyone should own a car, and then we all got a car. The benefit of a car is it's point to point. I can go from any point A to any point B. How do you guys think about the challenge of it's such a pain in the ass to go to a port, just like it's a pain in the ass to go to a bus station, take a bus or subway, go to a spot. In New York it works where things are dense enough, but in most cities in the United States, this is it is preferable to take a car because I can do point A to point B, and my convenience, my time, is always faster taking a car. How do you kind of think about the calculus of the benefit here when I have to go to a port to be able to take the vehicle to the next port?
I think you're spot on. I think of where we are today as very similar to where the automotive industry was in the 1890s, where it was before we had the ability to mass produce cars. We were building tens and then hundreds of cars, and that didn't give the scale. And so what we were using cars for was taxis. We are in a similar mode today where we are going to use these aircraft as taxis. We still need to save people time, and so there's only going to be select routes where this is a game changer because of the multimodal nature, where you need to, and you may not have a takeoff and landing location exactly where you want to leave from and go to. But over time, if we can get the acoustic signature down, if we can make these aircraft even quieter than they are today, rather than needing to go to a dedicated vertiport to do this, the dream is to eventually be able to land them at your house.
Adam, let's talk about propulsion for a second. Energy density, cost, those trade-offs, speed, these are all variables that kind of just work opposing each other. What were some design decisions you guys made, and Did you have to remake some of those? Did you change your mind at some point? And just walk us through that process.
The biggest challenge, I think, of building these aircraft is just the time it takes to do it. It is very expensive, and it does not fit any typical model, meaning the venture guys don't like it. And so they're like, sorry, you want $1 billion up front to build this? Like, that's terrible. You rejected me. I don't think I met with you. Like, everybody rejected, probably all of us up here. And so it's not a typical, you know what I mean? Like, mom, that's the reality. So there was this crazy period of time in 2021 where the capital markets opened up. It was a dream scenario. We could raise a lot of money from the public markets. That was nuts. So that allowed this to happen. And then from there, for me, what we did was we said, okay, what is the business case? Meaning, we thought when we looked at like, what are these, we call them hero routes, where there's a lot of people doing these trips like Manhattan to JFK. It's like 30 million people go from Manhattan to one of the 3 big airports in New York. Okay, so all we have to do is...
That's a no-brainer.
Yeah, all we have to do is have a couple around the city, which already exist. There's downtown, Wall Street heliport, West Side, East Side
heliport, yeah.
And just put them into the 3 airports. And that'll be an amazing thing to start with. Okay, so short routes, 20 to 50 mile routes. Now let's design an aircraft around that, the fastest thing we can do to get to market, so we don't die before the investors decide, nah, we're kind of like done with this one, now on to the next thing. Oh, AI, here, let's everybody go all in on AI. And so I'm just moving as fast as we can. So that was the biggest trade-off. So it was always, what is the minimum thing we need to do to get that done? So you need to look at speed, range, and payload. Payload is definitely the hardest because batteries are heavy and there's just physics you're always fighting. And then speed, the difference between these planes want to fly around 120 miles per hour. If you go faster, it's just more drag. It kills your battery faster. So the difference between 120, 150 on a 10-mile flight doesn't really matter. It's more of how do you go at least that 20 to 50 mile route and go at least, call it 120 miles per hour and do that as fast as possible.
And what kind of batteries? What kind of batteries did you guys choose?
Lithium-ion cells, commercial off-the-shelf stuff. Molicel makes. You can find the cells today. There's millions of them that are made in power tools and supercars and pretty conventional off-the-shelf
What's
stuff.
the range?
The range of the aircraft?
Yeah.
We're designing to go up to 100 miles, but the real design is around rapid back-to-back 20 to 50 mile trips.
What do you guys all need in terms of battery technology improvement from where we sit today, or do you not? And what's on the horizon in terms of battery technology improvements? What does that unlock in terms of range?
Yeah, so the batteries that we're certifying our aircraft with have a specific energy of about 300 watt hours per kilogram. To put that in context, when I started the company in 2009, we had cells that had sufficient specific power to do a vertical takeoff, but also we're at about 170 watt hours per kilogram. So we've almost doubled the specific energy in the cells over the last 15 years. That we have cells in our lab, and then there's a third dimension which really matters is the life. And so we have the cells we're taking the certification give us a 10,000 25-mile flights. So our kind of sweet spot is also in that in those shorter range flights, and we want to be able to do a lot of flights between replacements, both for the environmental impact of it, but also from the economics of replacing those battery packs.
And when the plane takes off, that's a lot of energy usage. The wings tilt forward, and now you're flying more like these Ospreys as a plane. The energy goes way down the consumption, and then on landing, you got to be very careful and use a lot more energy. Is that correct?
Yeah, and there's different trade-offs that you can make. Basically, the more propulsors you have, the smaller each propulsor is, and the heavier your disk loading, and the higher the amount of power you're using in hover, the harder you're pulling on the batteries. But then more propulsors also gives you more redundancy. So there's a trade there.
Brass tacks. When do you each think we're going to pick a quarter and a year? So fourth quarter 2025, second quarter 2026. You all have to answer it. You agreed backstage. And Americans will be able to give money to get in one of these, not a test flight, in a major city in America, to when we all be able to use it. Not just yours.
These guys should answer for themselves, but I think they'll get it done in 2026. And you should yell
Pick
at me
a quarter.
if you think it's different. Man, I don't know.
Q4,
First quarter.
be safe.
First quarter.
Oh, give us
26. I want to give them some heat. We'll be a couple years after that.
But that's an incredible thing. I mean, we're less, a year plus away. That's crazy.
Now you should tell me how you feel about my expectations.
Yeah. I think pretty clearly there's a route to do this internationally next year. And so I think we'll launch with passengers next year.
He said in the U.S.
I know, I'll start there.
that's
I'll
fine.
start there
I'll allow
in 2025. My job is to make sure we have a safe
Which
aircraft.
quarter?
I think probably fourth quarter.
Perfect.
I think my job is to create a safe aircraft. If Pete Buttigieg called and said, hey, there's a way to do this in the US, I'm gonna help cut through all the red tape and we're gonna help you get it done, like my phone's on, I'm ready. Call me, I will find a way to do it.
I would love to have Pete. Why did we invite Pete? He seems dynamic.
So he
What do
was
you got?
actually, we nearly had him.
Yeah.
Very close.
So I think we're on a timeline which we publicly announced to begin commercial service in the UAE next year.
You think Q4 2025 as well?
I think it's likely
Or
at the
Q5.
back end of. I think it's
Q5?
at the back end of next year.
Well, let me ask
How
you guys.
much though?
Yeah.
I just want to get
I
the
mean,
cost.
we will begin begin operations before that, but we will not in
Have you
terms
guys
of being
figured
able to
out-
buy a ticket.
Have you figured out the flight profile that you're going to start with? Like it's airport to X or something like that? Or
We have 4 vertiports that are that we're planning to build in Dubai, and the RTA, which is
I would like one from the airport to the Win, which opens in 2027.
Yeah, from Dubai to the new win.
They're opening a
Well,
win.
it's a little far because it's in Iraq, so it's a little far away.
There's a
from
win
me.
in Dubai that's opening.
in Ras Al
Yeah,
Khaimah.
they're opening a Win.
That's sick. We gotta go.
All kidding aside,
That's awesome.
I want to talk to you guys. We talked yesterday with Elon about this. He said it's taken longer to get approval to launch Starship than it did to take launch. So it's this sort of push on regulatory we're hearing over and over again. You work with the FAA closely. Can you just describe the path to bring them along, get the certifications that you need, and how much of a push or a pull that is in each of your businesses?
Yeah, I mean,
Brian,
I guess I'll just start, obviously from the autonomy standpoint specifically, we're trying to push the frontier. And so whenever you're engaging with a regulator, no matter if it's aviation or if it's biotech or some other thing, if you're really, really on the frontier, it means that the regulator doesn't necessarily understand the technology any better than you do. And so a part of it needs to be kind of a journey where you're going together to really learn how to make it safe. At some point, you need to be regulated. There needs to be a process of you putting forth, engaging in what are the requirements, you putting forth, here's how we're going to meet those requirements, and then there's a process. I think that, honestly, from my standpoint, that actually works okay. I just wish that it was a little more responsive or engaging on some of the deep technical subjects that we have to advance.
Do they have the people inside the FAA?
That's part of the challenge. So part of the challenge is that in aviation, partially because of what Peter Thiel said yesterday, there's sort of a generation of, if you went into aviation, when I went into aviation, the demographics were completely upside down. People were retiring, new people weren't coming into the industry. And so many of the experts in the FAA that have regulated some of these systems that have created really safe airplanes have retired. There's a lot of new people coming into the industry, which is great, but don't necessarily have the expertise of having built some of the systems that we're now building. And so there's some way that we almost need to get people to come through the industry and then...
I think this is a really important point, and it's counter to what RFK Jr. has been saying over and over again, and this is why I push back on him. I'm sorry, this is off topic. There is a very important reason to have people from industry become part of the regulatory framework for regulating the industry. Because if they don't know how, and they're going to have a complete aversion to embracing technological innovation. That's why I think it's important that there is a rotation of people that are, consequentially not economically motivated in some way, but that understand the technology and can motivate it. But in that framework, let me ask you guys, in markets where there is a regulatory framework that allows for accelerated output of innovation, let's take China for an example. There's a good A/B test maybe underway right now. What companies are doing eVTOL technology in China? How good are they? And then given the way that the Chinese government can kind of step in and accelerate outcomes, are we going to see and are we seeing eVTOL technology kind of coming to market fast and in a kind of accelerated way in China, like we're seeing with nuclear and other tools that the government's saying is a priority and a mandate?
Yeah, I mean, you have EHang and Autoflight, and they're
Those are Chinese companies.
and a bunch of them are making great progress. There's a lot of enthusiasm in China. The regulatory pathway there is more forward-leaning, I think, as Adam pointed out, and I think you're going to see more rapid iteration. I think the good news here in the U.S. is that the FAA is in the process of releasing something called Mosaic, which for aircraft that are smaller than ours, aircraft with like 2 passengers in them, more of a personal ownership type of thing, that's going to allow much more rapid development and a lighter touch from the FAA. Just to put this in context, the FAA has done, I think, an incredible job, and they've really been leaning in. When I went and first talked to them in 2009, they thought this was like absolutely crazy. Like, they just did not think we were going to be able to build an electric aircraft, let alone one that could take off and land vertically, and which was quiet and all these different dimensions. We then, began working with them regularly in 2015, began formal certification in 2018, had our stage 4 G1 in 2020, G2, and then G3, and now we're working on stage 4. So with each, we are building momentum. We're writing all the rules. It's very heavy lifting, and
Joe Ben told me once, because Joe Ben has been kind of the first through the pipeline there, and he said, I feel like a pipe cleaner for how to certify these things. And I guess there's one thing I would just throw into the regulatory context, just because I think you bring up a good point, is it's not like these things were sitting on the shelf and a regulator was sitting somewhere saying, you can't use that. We have been on a journey that we just all talked about, getting these things ready. So they're now just at the point where they're ready. And the question is, can we take that first step in the US to really get it done?
And does the US, do they approach that from a culture of, let's just try something. If we get it wrong, we can iterate it? Or is it more, we must get this right because there's all kinds of consequences, political or otherwise?
It's so much more simple than that. They want to do it. The people at the top are actually genuinely very excited. Former FAA administrator Billy Nolan stepped down from his role, joined Archer. The new one, Mike Whitaker, came from an Evtol company. They were very excited to do it. The challenge is, with probably most regulatory setups, is not a lot of incentive. It's not like there's a downside to not doing it. A lot of disincentive to do it, meaning if something goes bad, there's only downside there. And it's a slog and it's hard. Like, this is hard. This is not easy to go through all this. The incentives are not great. And then on top of all of it, there's no policy saying, hey, America needs to be innovative. We need to go do this. Let's go and get it.
Why is there
There's
no
culture
mandate?
to do it.
Like, it would be great if some leader said, you guys need to get this done, and we need to have these things flying safely in the next 36 months. Like, how does that happen in our current system? I can understand how it happens
Trump
in
literally
UAE.
put out a video on it. He put out a video, agenda number, 39 or something like that, where he talked about building future cities.
If you're enjoying this, please bang that subscribe button.
I'm guessing he went to Dubai and then...
But is that something, Adam, that we could change through an executive order?
I think it's culture you have to change, meaning like, we will do this and break down all the barriers to get it done, because it's not that hard. Like, you can, we've all laid out the rules to certify. Like, why can't you let us just go do the tests? And then if we do the tests, you check them off, we're good. It should be that easy.
If you're a bureaucrat, if you're working in one of these organizations, if it goes poorly, you're in big trouble. If it goes well,
but are you though?
Well, the SEC had this mandate. It's very similar to allow more accredited investors, sophisticated investors, allow people to take tests, and to just allow more access to private companies in investing, which would be good for a company like yours.
Jason, just to build,
and they have slow walked it. So I think that's part of the problem. Is
but just to build on what Adam's saying. Okay, let's just say the SEC doesn't do anything, or they do it and they make a mistake. Nobody at the SEC will get fired. Just like I don't think the culture is that if if a commercial airline has an issue, or for example in the 737 MAX issue, did more people at Boeing get fired? Did more people at the FAA get fired? Or did nobody get fired?
Nobody.
Aviation is different on the in the comparison with the SEC as an example. Like, aviation is different. Like, actually aerospace is different. And I would just call out one thing that I saw on the stage yesterday, which really hit me. If you saw Elon's face when he talked about the safety of the astronaut, Like you saw his face.
He was almost crying.
Yes, he was almost crying. And that's what aerospace is all about. And so there is the reason that the industry has been able to get to that unbelievable statistic that I just talked about is that it's gone through awful accidents. It's gone through terrible things that have happened and have turned into the rules that we are now all being regulated towards. What's happening now is that we're showing up with new technology. So I'll give you an example, like regulations. They currently say the pilot shall do X. And it says that 50 times. Well, we don't have a pilot. And so when we're showing up, we have to kind of rewrite what that is. I understand why it says the pilot shall do X. It says that because there were accidents in the past that have now been regulated out of existence.
But you're also looking at it from the negative point of view. How many lives could be saved if we got this stuff into, pick a country, India or Africa? We could bring clean water and medicine and supplies to people. Disaster relief. It doesn't cost $10,000 an hour to fly a Black Hawk anymore into some disaster relief situation. It costs $500 an hour, and we can send 50 immediately. Then they're always available. The uptime is super huge. And so I actually think you could save a lot of lives too if you.
And what about saving lives here in the U.S.? We lose 40,000 people every year on the roads,
which is insane.
And we fly almost as many miles as we drive. So like driving is more than 10,000 times more dangerous per passenger mile than flying is. So we could actually, by moving people into the air for their daily transportation, save thousands and tens of thousands of lives.
Now, if you want to hear more of Joe, Ben, and Adam speaking, make sure to check out this video below.